Dear student, myself Rajendra Aaseri, I am Assistant Professor in Computer Science Department at Government Bangad PG College, Didwana. In the previous lecture, we discussed various concepts about database and management system. Why the requirement of database is there, what are the various drawbacks of the file system, various levels of abstraction in a database, in database design, what are the various models like ER model, object oriented model, network model, all these basics we have discussed. After that we have discussed about SQL, database architecture and various users which play an important role in the database architecture. All these concepts we already discussed. Now in today's lecture, we are focusing some new concept. Okay. So first thing is relation. Up to this point or up to this lecture, I used the name relation many times. What basically relation? So relation is nothing else, it is a name of the table, relation name, right? In a relation, we are having our data. Our data is organized in a form of a table. Suppose in this particular table, uh, there are three columns. First column is account number, second column is branch name, and third column is balance. So it is basically a table of three columns. Now if you see, there are total 7 rows are there, and row is named as tuple. Row is called as tuple. So there are 7 tuple or 7 rows or 7 records, right? A101 is the first account number, A102 second account number, A201 third account number, A215 fourth account number, fifth account number, A217 sixth, A triple two, and seventh, A305. If you notice, all these 7 entries are corresponding to account number are different. It means it can be used to distinguish for, the other columns, right? Okay, so in relation, the name of the column is called as what? Attribute. Okay, name of column is called as attribute, and in a particular attribute, suppose account number field, all the values are called as domain. In a particular row, all the entries are called as a particular record. Okay, suppose A101 downtown and 500, it is first record. Similarly, A102 Paris and 400, this is second record. Similarly, this is the account number, this is first domain for the account number, second attribute name is branch name, this is domain for the second attribute, and third balance is the attribute name, third attribute, and this is the domain for the third attribute. So in this manner we can organize our data in the form of table, which is known as a relation. Okay, now basic structure. Formally we are having some sets like d1 d2 dot up to dn. A relation R is a subset of d1 into d2 into up to dn. Means if we cross multiply all the set, suppose a simple example I am taking, just in mathematics. Suppose this is a first set, right? The set name is suppose A, and second set is B. In B set we are having a number 3. So if I am doing A into B, it will be having 2 into 1 2 3. Or suppose in the B set I am taking 4 3 and 3 and 4 second. Okay, so 3 and 4 in B, and in A 1 and 2. So two element in the first set and 2 element in the second set. So total 2 into 2, that is 4 element will be there in the multiplication set. Clear? So we can say that if we are having different set like d1 d2 up to dn, then a relation is subset of the cross multiplication of all the sets. Okay, thus a relation is set of n tuples a1 a2 up to an, where each of the tuple is subset of the d. Okay, example. Suppose I'm saying customer name. So there are various customers like John, Smith, Curry, Lindsay. All are the customer name. Okay, so customer name attribute will contain all the customers. So this is same as the, we can say, domain. Domain means all the possible value corresponding to a attribute. Clear? Similarly, customer street, main, north, park, all this is a set of all the street name. Third is customer city, Harrison, Rye, Pittsfield, all the city names, set of all the cities. Okay. So we can say the relation is the combination of all these: customer name, customer street, and customer city. The all the attribute comprises, and in a single unit form it will make a relation. So is a relation over customer name, customer street, and customer city. So in this customer relation there are three fields: customer name, customer street, and customer city. Okay. So this is all about the basic structure of the database or relation. Now attribute type. We can have different type of attribute. First thing comes in all of your mind, that what is attribute. So attribute is nothing else, it is a property which tells about the record or about the entity. Entity means a real life object or thing which has some property. The property is called as, in the technical term, in database term, attribute, right? So each attribute of a relation has a name. First point, every attribute should be having a name. Without name there doesn't exist any attribute. Means we cannot have a column which doesn't have the heading. Suppose in the previous example, in this example, account number is the attribute, branch name attribute, balance attribute. If I am not writing here balance and just empty, then it cannot be a attribute. So attribute name should be given. Each attribute is of a relation has a name. The set of allowed values for each attribute is called the domain of the attribute. This already I have explained. All the possible value which can be allowed in a particular attribute is called as, in combination, domain of the that attribute. Now attribute values are normally required to be atomic. Now what do we mean by atomic? Very important property. The meaning of this is that individual. In individual means I am saying that phone number is the attribute name, and in the in a particular customer corresponding to a particular record, phone number attribute is having two value. It means it is not atomic. Clear? Example, the value of an attribute can be an account number but cannot be a set of account number, right? Well, means single account number or single entry, then okay, but more than one entry, then it is not a atomic, it is a multi, we can say more than one possibility is there for that particular attribute corresponding to a particular record. Now domain is said to be atomic if all its members are atomic, right? So the whole domain will be said as atomic if all the possible entries in that particular corresponding records of all or all the tuples is having a single entry corresponding to that particular domain, then domain is called as atomic. Now the spatial value null is member of every domain. Means in every domain there is by default one value is there, spatial value, that is null. The null value causes complications in the definition of many operations, right? So we shall ignore the effect of null value in our main presentation and consider their effect later. What is null effect? We will just ignore in this particular presentation, and what is the actual role of the null values, we will be learning about that, understanding about that in the upcoming lectures, right? Okay. Now relation instance, relation schema and relation instance already I explained. Here we are going in much depth. Now schema is the overall structure of the database. Means in the overall structure there are some ingredients are there: name of the relation, number of column, number of rows, name of the attributes. Okay, all this comes under the, we can say, schema. Now instance, the current values or relation instance of a relation are specified by a table. at particular time in a relation or table, what is the status, how many rows are there, what are the values of the rows or records is called as instance of the relation. Now in an element T of R is a tuple, we can say T is a tuple of relation R represented by a row in the table. So if you notice in this particular example, so in this example, customer name, customer street and customer city are the attribute or column, and there are four records or four tuples are there. Okay, first record is corresponding customer name John, customer street name is Main, and Harrison is the customer city, and so on in this particular relation. Now relations are unordered. Order or tuple Order of the tuples are irrelevant. Tuples may be stored in any arbitrary order. Example, account relation with unordered tuples. Suppose I am saying that A101 should be always put at first line. It doesn't matter, right? If A01 is at the, we can say A01 is coming after A217, then again the instance of the relation doesn't, we can say doesn't change or modified. So the order of the tuple is irrelevant. We can alter, or in alteration in the order of the tuple doesn't change the overall structure or overall instance of the database. The next is database. A database consists of multiple relation. Up to this point we have just discussed only one relation. So in a database there can be number of relation, right? Suppose in I am assistant professor in a particular government Bangalore PG college. So here various database can be built, like faculty database, student database, course database, fees database, different uh, in fees database we can say course name, okay, course name, year, uh, regular or part-time. So accordingly fees can be vary. So all these relation in combination comprise or in combination result into a database. Information about an enterprise is broken up into parts, with each relation storing one part of the information. Example, suppose in banking scenario, account which store information about accounts, depositor which store information about which customer owns which account. So relationship between account and the customer stored in depositor table, information about various accounts stored in account table, and in customer table it store information about the customer name, customer ID, address. Clear, all these information comes under customer category. So the each relation will just, we can say, store a corresponding separate information. More than one table can use the duplicate information also. So in that case foreign key concept comes into picture, which we will discuss in the upcoming lecture. Now storing all information as a single relation, such as bank account number, balance, customer name and all, will result in repetition of information. If in the previous case I have written that three relation I am making, if I am just adding all these three relation and making a single relation, then what are the drawback? It will result in repetition of the information, or redundancy will occur in the information. Example, two customer own an account, so what gets repeated, right? The need for null values. Example, to represent a customer without an account, then corresponding account entry of the customer who is having not doesn't having an account, then we need to just put the null value. Normalization theory deals with how to design relational schema. So in order to effectively design the database, that how many relations should be there in a relation, a single relation is enough for a particular database, or how many number of relation should be there in a relation, a big relation should be divided in a further small relation, how we need to do this. For that, normalization theory is there in database. So various forms are there, normalization forms are there. By default every database should be in the one and enough form, first normal form. then second normal form, third normal form is there. For every normal form there are some certain conditions. So if a database just we can say satisfy a particular condition, then it will be in that particular corresponding normal form. Okay, so we will be discussing all the normalization technique also in the upcoming lecture. Now next, here I have given some example. Customer relation, customer name, customer city and customer state, three field are there, and 12 rows are there, 12 records are there. We can just add some more records in this particular relation. So customer relation comprise 3 column or 3 attribute and 12 rows. Next is depository relation. Depository relation just give the information about the mapping between accounts and the customer. Means it is having entries of those customer or those customer name which are having the account. So if you see here, 7 customer from the customer relation is having account. So those entry will be put in this particular depository relation. So it will show the relationship between the customer and the account number, that is the name of all the depositors. That's all from this particular lecture. In the upcoming lecture, some more exciting concept about the database going to come. That's all from this lecture. Thank you.